Okay, I'm going to talk about recursion. Now, recursion is pretty widely used in programming, and it generally involves taking data, looping it until you reach a stop case, and then returning the modified data. So this generally involves passing data into a function, and I'm going to talk about what a function is. So you can think of a function as, let's say, like a factory. So we have a factory here. And if we take data to be a tree, we can input this data into the factory, and with the factory modifying the tree, it will return something like, let's say, a table. That is, if the factory is meant to make a table from a tree. So if we were to write in pseudocode how this function works, we could write the name of the function, so that would be factory, and it would take something like a tree inside brackets. So inside the brackets will be everything the function does. So if the factory takes a tree, we can have a process where, let's say, we cut the tree. So we're cutting the tree, and then this will give us, well, let's say we will get wood from cutting the tree, and with this wood we could, let's say, assemble it to build a table. So then we have a table is made by assembling wood, and then we return the table. So this is a simple example of a function, and if we were to tailor a function for recursion, we could give an example. Let's say we have a piggy bank here, and with this piggy bank, let's say we pass it into a function that we're not exactly sure what it is, and the output of this function is the same piggy bank, but instead it has, the only difference is that it would have, let's say, $1 inside of it, and originally it is empty. So we could say that this function adds $1 into the piggy bank. And recursion is essentially if we were to have this piggy bank, the modified piggy bank, and have it call the same function again. So let's say we would call the same function again. This would get passed into the same function over here. These are the same. And with this modified data, we'd get piggy bank back again. And inside here, it would have $2 because the modified data is given another $1, and this returns $2. And this is essentially recursion. We have the type of data, it goes into the function, get the modified data, it goes back in the function over and over until we reach a stop case, which is when we want this looping to stop. So if we were to write some pseudocode for this, we could say, let's just call it box. Box would be the function name, and it would take a piggy bank. So a piggy bank is passing the box. We could say we add $1 to the piggy bank, so add 1 piggy bank. And then we would call the function again. So with this modified piggy bank, now this piggy bank is $1. If we were to take a piggy bank with $0 and we pass it into the box function, and with this addition we get a piggy bank with $1. So with this piggy bank with $1, we can call the function again. So let's say box piggy bank. This would essentially repeat the cycle over and over again, like we've seen here. So again, we have piggy bank with $0. It goes in the function. It gets $1. It's passed back into the function. $1 is added, and then we get piggy bank with $2, and this would go on forever and ever. And since it goes on forever and ever, it's not what we really want. We want to reach a certain case, and then we stop. And that's generally known as a stop case, which is just a check at the beginning of the function before we modify the data. So this would be the stop case, and let's say we want to stop, let's say stop if piggy bank has $4. So let's rewrite the function. We could say box piggy bank, and we have a check. So check's generally done using an if statement. You have if piggy bank is equal to $4. Piggy bank is equal to $4, then we will exit. Otherwise, or else, we will add $1 and then we call the function again. That's the end of that. So as you can see here, let's go back again. We have a box, we feed the piggy bank, it checks whether it has $4. Currently we would say we have $0. Let's say it's a brand new piggy bank. And then since it has $0, we'd add $1 to it. So now the piggy bank has $1, and then the piggy bank with $1 is sent back into the function again, and it checks if it has $4 or not. It doesn't. Add a dollar. This continues until we have, let's say, a piggy bank with $3. It doesn't have $4, and then we added $1, so now the piggy bank has $4. And then when we pass it back, we check that yes, the piggy bank indeed has $4. So then we exit, and then we're left with a piggy bank with $4. Now this is the general structure of recursion. The code is just pseudocode. It's not necessarily real. It doesn't compile. So this is just the concept. You can apply this to any programming language of your choice. I guess so long as it has the ability to use functions. And recursions are pretty common. Again, you could use them in something like searching a list or a tree or an array perhaps. And also maybe if you want to calculate something like Fibonacci sequences, Fibonacci numbers, you can use something like recursion.